What is the remainder when the positive integer n is divided by 12? Okay, so we don't know anything about n, so we can pretty much just start with the statements. One thing that we can keep in mind, though, is so when we're dividing by 12, what does that mean? So our remainder always has to be less than our divisor. So in this case, our remainder must be less than 12. So our options, even before we know anything about n, for a remainder are 0 through 11. So keeping that in mind, now let's look at the statements. So statement 1 says when n is divided by 6, the remainder is 1. So this sort of presentation, or this sort of statement format, is something I'm very used to sort of recognizing, because I can translate this into an equation. And so sometimes I present it this way, or something I say, when something is divided by something, the quotient is something, and the remainder is 1. So in this case, what they're saying is n is equal to 6 times x, and x is just some quotient, or you can think of it as some integer multiplier, plus 1. And so with this equation, I can sort of very quickly generate a bunch of examples of n, because when x is equal to 1, n will be equal to 7. When x is equal to 2, n will be equal to 13, and it will go up by 6 every single time. So I got 7, 13, 19, 25, 31, 37, 43, 49, etc. So now we're going to start calculating some remainders here for when I divide by 12. So these are all possible values for n. So 7 divided by 12, what will the remainder there be? So that will actually be 0, remainder 7. What is the remainder when 13 is divided by 12? So that would be 1, remainder 1. So here, I am actually done, because I have 2 different possible remainders. So this will be insufficient. Statement 2 says when n is divided by 12, the remainder is greater than 5. Okay, so I mean, we already said that if unless we know something about n, we already have 0 through 11 are options. So in terms of possible remainders greater than 5, we can have 6, 7, 8, 9, 10, 11. So by itself, this is going to be insufficient. So really, we just got to look at them together. So now we could continue doing what we're doing here, where we calculate out these remainders, but then we can only use ones that are greater than 5. So 19 divided by 12, that will be what? 1, remainder 7. 25 divided by 12 will be 2, remainder 1. So I'm starting to notice a pattern here. 31 divided by 12 will be 2, remainder 7. 37 divided by 12 will be 3, remainder 1. 43 divided by 12 will be 12 times, it'll be 3, remainder 7. And let's do 49. 4, remainder 1. So, but what do we know now? We can only choose the ones that are greater than 5. So all of our ones don't count. And we know that our remainder has to be 7. So C.